Alright, so I'll pick up from where I left off in terms of reflection over the y-axis. So you have your square root function, 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So we want to reflect, which we're going to change the x value. So if we change the x value, then we're reflecting over the y-axis. And so all of these values from the parent function will get reflected over the y-axis. So the 0, 0 stays. The 1, 1 becomes negative 1, 1. The 4, 2 becomes negative 4, 2. And the 9, 3 becomes negative 9, 3. And you can plug those values into the equation and see if they work. If you plug in negative 9, the opposite of negative 9 is 9. 9 square root of 9 is 3. Okay. And then h of x, you got two things going on. You have the reflection, which is the negative, and then inside here you have x minus negative 2. So there's two things. We are reflecting supposed to be an L. So we're reflecting over the, once again, y-axis. And then this one is going to the right. Or not to the right, I'm sorry, to the left. It's x minus a negative 2, so it's going to the left 2. So we're reflecting over the y and shifting left. Once again, if you shift left, you're changing your line of reflection. So we're going to reflect first, then shift left. So if the point is at 0, 0, I reflect over the y so it stays there, and then I shift left. So my new starting point is going to be at negative 2, 0. And then, once again, the point 1, 1, first we're going to reflect it over the y, and then shift it over 2. And same thing, the point 4, 2, we're going to reflect over the y, and then shift it 2 units. So if that makes sense, if I plug in negative 6 plus 2 is negative 4, the opposite of negative 4 is 4, square root of 4 is 2, so that looks good. And then the last one's not really going to fit because it was at 9, 3. So we would reflect and then shift it over 2, it would be a little bit farther over here. And so that's what happens when you reflect over the y-axis. Once again, think about what is changing. The x value is what's changing. Alright, and then the last part that we're going to be doing is our non-rigid transformations, which are our horizontal stretch and compressions. Our textbook uses the word shrink. Typically I use the word compression, but just make sure you know both in terms of using the book and talking in class as well. So if you take a look here, these are where you're changing kind of the shape of the graph, where you're stretching it out a little bit or compressing it. So I think of this kind of as a balloon. If you think of a balloon and squeezing down on it, what happens to the shape, and then if you pull on it, what kind of happens to the shape, makes it more narrow, things like that. The vertical one, so once again, think about this. The vertical is up and down. Okay? So what changes when you're going up and down? Well, the y changes. So look where your multiplier is. The c is being multiplied by the g of x. So the c is being multiplied by the function. So each y value is multiplied by c. If it's greater than 1, then it's going to be a stretch. You're pulling it kind of farther away. If it's between 0 and 1, multiplying by a half, 2/3, things like that, well, then it's going to get smaller, so it's going to shrink when you multiply it by 1/2, 2/3, things that are less than 1, greater than 0. With horizontal, we're going this way. So if you're moving this way, what are you changing? Well, your x value is then changing. So look again where your multiplier is. It's being multiplied by the x value. Now with a horizontal stretch and shrink, if you look at these two, the stretch of a vertical was greater than 1, but the stretch of a horizontal is actually between 0 and 1. But here's the difference. Each x value is multiplied by 1 over c. So if we're going to be, if c is 1/2, we're going to multiply the x value by 1 over 1/2, which is 2. So that's why it's getting stretched out. With the horizontal shrink, the vertical shrink was between 0 and 1. Horizontal shrink is, or compression, is greater than 1. But once again, you're going to multiply the x value by 1 over that, so it'd be multiplying by like 1/2, 1/3. And so it's shrinking then. So let's look at a couple here. We got 3x squared, so the 3. Is that being multiplied by the x or the function x squared? It's being multiplied by the function x squared. So in this one, this is a vertical stretch by 3. So all of these values over here on my parent function x squared, the vertical, so it's going to be changing the y value, is going to get multiplied by 3. Well, 0 getting multiplied by 3 doesn't do anything, so that stays at 0. 1 getting multiplied by 3 becomes 3. And then the 2, 4, the 4 would get multiplied by 3 and become 12, so that'd be somewhere up here. And on the other side, it's happening the same thing. It's, 1 getting multiplied, or negative, 1 getting multiplied by 3, and then the 4 getting multiplied by 3. And so if you can see here, alright, then it is a vertical stretch. So you can see, not the best graph, but you can see how it got stretched out, so it got more narrow. On this one, we have the 3 being multiplied by the x value. So with the 3 being multiplied by the x, that means once again the x is changing. So this is a horizontal stretch or shrink, stretch or compression. So since it's being multiplied by 3, that 3 value is greater than 1, and so we're going to be compressing this one. Okay, but horizontally. So if you compress it horizontally, it's going to look like a vertical stretch as well. So if you need help on this one, maybe write your table out in terms of x and y, and this would be your parent function. So we'll do -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. What is changing? Well, since it's being multiplied by 3, it actually, since it's a horizontal compression, it's actually getting multiplied by 1/3. That's the 1 over the c part. So all your x values get multiplied by 1/3. And so what happens is all of these are actually going to turn into fractions, so it's going to be a little difficult here, but we'll do 3, 9. And so they all get multiplied by 1/3. So the 0, 0 once again stays there. The only one in terms of the x that's easy to multiply by 1/3, I'll do -3 also in 9, is really these two. So if we multiply them by 1/3, these will turn into 1, 9, and -1, 9. So that's how much these are going to get stretched out. So you can see how narrow that is.
Daddy?
Yes, Evelyn? You want to say hi to my class?
I tuned it in the front room.
You tooted in the front room? Did you say excuse me?
Recently.
Okay. Tell my class hi.
Hi.
Alright. Hold on, let me finish up here, okay? And so that represents a horizontal shrink. Once again, looks like a vertical stretch as well. So that is it. That was that ended on a good note. Your homework is on Schoology. You can take a look. It's actually right here as well. So we're going to talk more about the transformations in class. This is a challenging thing, especially if you haven't ever understood it before and you tried to memorize it before. So once again, we'll talk more about this in class. Thanks. Have a great day. Evelyn, would you like to add anything to the end?
Maybe a smiley face.
Maybe a smiley face? Here, draw them a smiley face. That's good. Anything else you want to draw them? That's it? Okay. Alright. Say bye.
Bye.